Hi everyone, we're going to look at all key features of a function here, which is a lot of things for just one function. Let's start off with the first thing, which says finding the parent function. So the parent function is basically what produced this function. That's why it's called a parent function. So what does this function look like if you take away all the numbers? So we've got a +4, a -1, and this little negative. Well, if you take those all away, that would be f of x equals just the cubed root of x. That's the parent function. That's the original function that produces this new transformed function. So the transformations that are done are each of those individual things. So we always start with order of operations, or we use order of operations to figure out where to start. So this x plus 4 is the closest thing to x. Think of it as like being in parentheses there. So for your order of operations, parentheses would always come first. So the +4 we're going to do first for our transformation. So the +4 is kind of the opposite because it's going to be inside with x. So if it's a +4, it's actually going to be a horizontal shift left 4. So horizontal shift or translation left 4. And then we go kind of out from there. So the negative would be next, this -1 in front, because that would be multiplying before we do the subtraction over here. So the negative in front is going to be multiplication again, which is reflecting over the x-axis. That's the flipping over the x-axis reflection. So we're going to do that one next over the x-axis because all the y values would be negated, which if they were negative, now they're positive and vice versa. And lastly, the -1 would be the last transformation, which is a vertical shift down 1. This one is kind of what you'd expect. Vertical shifts up and down are going to make sense because g of x is y. So when I say -1 to what used to be y, it's going to do what you'd expect. So it's going to go down. The horizontal shifts are kind of backwards because x is trapped in there, that function, and if you were to solve for x, it would make more sense because it would go in terms of x and it would be what you kind of expect. Those are all of our transformations. Now let's look at the graph over here of our function to find domain and range. So this function does continue forever. It should have arrows on the ends there. So the domain, always think what x's work and which x's don't work. So in this case, this thing goes forever and ever. There's no places where there's any holes in the graph or any places where you divide by 0 or anything like that. So everything's going to work for the domain. So it's going to be all real numbers. Or we could say -infinity to infinity using interval notation. For the range, it's actually going to be all real numbers as well. This would actually always continue upward. Well, it would start from infinity, and then it's going to, positive infinity, and then as it goes to the right here with the x's, it's going to reach all the negative numbers as well, which is kind of crazy. But the reason is, no matter what I use for y, I could solve for an x and it would give me it. So for example, 1,000 equals negative cubed root of x plus 4 minus 1, I could solve this for x and get an x value that would do it for any value of x. So it's going to, again, be all real numbers for the range. I'm going to write the interval here using inequality notation just to mix it up a little bit, like that. So this is inequality notation, this is interval notation. Make sure you never include the infinities because you can never actually go to those numbers. They're not actually numbers that you could plug into a function. So that's domain and range. Now just for increasing and decreasing, start from the left side of this function, draw a little person if you'd like, and then just see what happens as you kind of follow this person across the graph. So this person starts here, and they kind of do this, and they do this, and they do that, and they're never actually going to increase. They're always sliding down. A little bump here in the middle, but they're always sliding down. So this person, this graph, is always decreasing. So for increasing, it's going to be none. And then for decreasing, it's going to be everywhere. So -infinity to infinity would be your decreasing interval. So that would be all the key features for this graph. Let's just do one more example here to make sure we got this. So here's another graph. Let's start with the parent function. So you can see here the -4 is extra and the -3 is extra. So what would it be without those? Well, that would just be the parent function f of x equals the absolute value of x. This is our classic V graph that looks like this, where everything is positive. But now it's upside down because that negative made everything negative. That used to be positive. So that's our parent function. So the parent function is just the absolute value of x. Next comes our transformations. Well, our transformations are everything that's different from f of x to g of x. And it's actually three things. We've got a negative, the 4, and the minus 3. Those are three separate things. So let's start in where x is. X minus 3 would be the first transformation there. So that would be a horizontal shift, right 3. It's kind of backwards from what you'd expect. Again, the minus actually goes right on the inside, and a plus goes left from the previous one. So horizontal shift right 3. And then moving outward, you can look at in this case, the 4 or the negative. Either one you could do first. Doesn't make a difference. They kind of go together anyways. I'm just going to do the 4 first, though. So the 4 would be a vertical stretch times 4. That's why it's a little bit skinnier than it would be normally. It would normally be like that, and it would be increasing faster if it was above, but it's actually increasing faster here and decreasing faster there. Whereas if it's up top, it'd be decreasing faster and then increasing faster. So that's the vertical shift, or vertical stretch, times 4. And then the last thing is that negative. So that negative, again, is a reflection over the x-axis. Let's add some colors here so you can see which part is which. So the horizontal shift there is the minus 3. Let's try again. The 4 is the vertical stretch, and the negative is the reflection over the x-axis. So three different transformations done to the parent function to produce this new one. For our domain and range, again, there isn't actually any problems here for x. I can plug in any x I want in for this x right here, and everything would work. So domain is everything, negative infinity to infinity, or all real numbers. The range, though, is not everything. I'm never going to get anything up here because it was all positive and then we flipped it. So now it's all negative except for when it's 0 right here. 0 is not negative or positive. It's kind of like the neutral number. It has no sign. So we want to say everything is below 0. So when you write this, be careful. You cannot write it like this. Oops, that should be a negative. We don't want to write it 0 to negative infinity. That's a no. You have to always go smaller to bigger. So everything from negative infinity to 0, we can have 0, we can't have negative infinity. Or this would be interval notation, or we could do inequality notation like this, and that would say the same thing for the range. Now for increasing and decreasing, let's start on the left side. Our little person, the little person starts here, climbs on up, and then slides all the way down. This is a nice little park slide here. There's a little ladder, there's a nice little slide. And that's how we can kind of visualize this, right? So the person is increasing up the slide and then decreasing down the slide. So our increasing interval would be everything to the left, which is negative infinity, up into this point right here, which is the point 3, 0. So increasing from negative infinity to 3, and then decreasing after that from 3 to infinity. Make sure for increasing and decreasing, it's always x intervals. Always x intervals. You can't do y intervals for increasing and decreasing. And when we do this, we don't include the 3. You could include it in one of them, but we don't want to include it in both. So make sure when we do increasing and decreasing, just to be safe, use open parentheses there to say that it's not increasing or decreasing at that point. It's increasing from the left, on the left side of it, and then it's decreasing on the right side of it. And that's all the key features of this function.